Hey YouTube, this is Illinois Math Tutor. I want to show you how to find the area of a regular hexagon. Maybe you're doing some geometry homework, maybe you're building something that has hexagons in them. You'll need to know how to find the area of a hexagon. Now the formula is 3s squared times the square root of 3 over 2. Now you could just stop here, that's the formula, that's all you really need to find the area, and s is the length of one side of the hexagon. But you might wonder, why is this the theorem? My explanation depends on you remembering a bit of geometry, like the Pythagorean theorem, but I'll take it one step at a time. Consider the following picture. It's possible to divide a hexagon into 6 identical triangles. Not only are they identical, they're equilateral. The formula for the area of an equilateral triangle is s squared over 4 times the square root of 3. And I have a handy little diagram of equilateral triangle WXY. The altitude to the base of an equilateral triangle bisects the base. All that means is that if you draw a line straight from the top of the triangle down to the bottom, that line will split that base into 2 equal pieces. So if xy is s, and also wy is s, then zy is s over 2. wz, the height of the triangle, is unknown. wzy is a right triangle, so c squared equals a squared plus b squared. You might remember that as a squared plus b squared equals c squared, but if you think about it, they're equivalent. Another equivalent way of saying it is hypotenuse squared equals leg 1 squared plus leg 2 squared. wy is clearly the longest side of that triangle, and it's directly across from the 90-degree angle, so wy is our hypotenuse. wy squared equals zy squared plus wz squared. Rearrange that to say wy squared minus zy squared equals wz squared. Now, since I want wz, I'm going to square root both sides. Square root of wy squared minus zy squared equals wz. Remembering our diagram, wy was equal to s and zy is equal to s over 2. So I can do a little substitution. This is a little tricky here. I have to do a fraction taken to an exponent. So s squared minus s over 2 squared. Well, a half squared is a fourth. So this is really s squared minus a fourth of s squared. And 1s squared is really 4s squared over 4. So 4s squared over 4 minus s squared over 4 is 3s squared over 4. That's just 4 minus 1. Now I'll take the square root of that to get wz. And the way you do that is you take the square root of what's on the top, the numerator, over the square root of the bottom, the denominator. That gives you s times the square root of 3 all over 2. And area equals 1/2 base times height in a triangle. 1/2 times s times the square root of 3 over 2. And that simplifies out to s squared times the square root of 3 over 4. Or if you like decimals, 0.25 times the square root of 3 times s squared. Okay. Now remember what I said about the equilateral triangle being 1/6 of the hexagon. If you multiply the area of the equilateral triangle by 6, it gives you the area of a hexagon with the same side length. So you do 6 times that formula from before, 6 times s squared times the square root of 3 over 4. Do some rearranging. 6 over 4 times s squared times the square root of 3. Simplify 6 over 4 to 3 over 2. And you'll get 3s squared times the square root of 3 over 2. Or again, if you're a decimal fan, 1.5 times the square root of 3 times s squared. To recap, the area of an equilateral triangle is s squared times the square root of 3 over 4, or 0.25 times the square root of 3 times s squared. The area of a regular hexagon is 6 times that, or 3s squared times the square root of 3 over 2, or 1.5 times the square root of 3 times s squared. Here's a little tip. If you don't have a calculator but you have your phone, open up a web browser, type 1.5 sqrt3 times 2 exponent sign 2. You'll get the area of a regular hexagon with side length 2, and that works out to about 10.39. You do not need a special character for the square root. So now you've seen formulas for both the area of a hexagon and the area of an equilateral triangle.